Hi, in the previous video we have been discussing one of the implementation of the queue interface and we have been discussing linked list. In this video we are going to talk about the priority queue implementation and basically priority queue based on a priority heap. I'm not sure whether you are familiar with heap. Heaps are tree-like structures like binary search tree, but we have some heap properties that we have to make sure that they are not going to be violated. It's not that important. What's important that we assign a priority value to every single item in this priority queue. So element with high priority is served before an element with low priority. This is why we assign these kinds of priority values. The elements of the priority queue are ordered according to their natural ordering or the priorities defined by the comparable interface. We have several methods, the odd, the peak, and the poll. This is how we add items to the queue with the help of this odd method. The peak method retrieves but doesn't remove the head of the queue, or it returns null if the queue is empty. And we have the poll method, which retrieves and removes the head of the queue or returns null if the queue is empty. So again, the difference between poll and peak is that for poll, we remove the item. With peak, we just return the value of the item without removing it. So let's take a look at a concrete example. We would like to store, for example, persons in a priority queue. So let's create a person. We will have the private string name and we will have a private integer age parameters. We will have a default constructors without any parameter and we are going to generate some constructor with the help of the integrated development environment. So right click, source, generate constructors using fields, and it's going to generate the constructor for us. I'm going to generate some getters and setters, so source, generate getters and setters for the age and the name. And I would like to override the toString method, so whenever we print out the person object, then this toString method is going to be called. So I'm going to return person plus this dot name plus some spacing and this dot age. Ctrl+Shift+F to auto format and let's save it. It's going to be the person class and we would like to instantiate the queue interface. So queue, we are going to store person objects. It's going to be the queue is equal to a new priority queue. Okay. And I would like to insert queue.odd. I would like to instantiate a new person with the name, for example, Kevin, and the age 22. Okay, then I would like to add another person, for example, Joe with the age 37. Then, for example, Adam with the age 12. Again, for example, Anna with the age 45, and then I say that while the queue peak is not equal to null, we keep printing out the queue.poll, for example. It's going to iterate through all the queue entities and it's going to get them from the priority queue. So if we try to run this application as a Java application, we are going to end up with an exception because person cannot be cast to a Java long comparable. That's what we have been discussing, that the priority is defined by the comparable interface. You may guess that the problem is that Java knows that, okay, it is a priority queue and it's going to get a person object, but it's not going to know that, okay, whether the priorities are going to be calculated according to the name parameter or the age parameter. So we have to tell Java that in the person class, this person is going to implement the comparable interface. Of course, it is generic, but we would like to compare two person objects. And of course, we have to or the unimplemented method, which is the compare to. So we get another person, and for example, we would like to assign the priorities according to the age parameter. So we are going to return an integer that compare to, and we are going to compare this.age with the other person.getAge parameter. And now, because we have defined that according to what we would like to compare the person objects, then we are not going to end up with an exception. So that's why, as you can see, it's going to be sorted according to the age parameter. Adam, Kevin, Joe, and Anna, because we have been defined that, okay, a person class, a person object is going to have the priority according to the age parameter. Basically, it's going to make an ascending ordering according to the age parameter. If we would like to assign priorities according to the names, we just have to use this.name.compare. And we are going to, oh, sorry for that. If we would like to assign the priorities according to the age parameter, then we just have to call this.name.compare to and other person.getName. And if we assign priorities according to this name field variable, and we run the application, as you can see, this person is going to be sorted according to the name parameters Adam, Anna, Joe, and Kevin. We are able to reverse the order if we put a negative sign here. And if we save it and run the application, as you can see, it's going to be the sorted order, but in descending order. Okay, so this is how it works, basically, this priority queue, and priority queues are quite important in graph algorithms. It is a good hint that usually we use algorithms and data structures in order to boost up much more complex algorithms such as graph-related algorithms. So shortest path algorithms and minimum spanning tree related algorithms relies heavily on priority queue. We have an edge class, and we have to compare edges when we are calculating shortest path, for example, and so on. So it is extremely important to know these built-in Java data structures in order to be able to use them as efficiently as possible. So this is how we use priority queues. It's very important that we have to assign a priority value to every single entity and every single item that we have inserted into the priority queue. Otherwise, Java is not going to know that, okay, we have a person class. According to what we would like to make the priorities? According to the name, according to the age parameter. So this is why we have to implement the comparable interface, and we have to define this compare to method to let Java know that according to what we would like to make the priorities. Thanks for watching.